Hi everyone, welcome to Linear Model with me, Sarini Abdullah. In this video, we will learn about stepwise procedure. In the previous videos, we already learned why we need to do variable selection. That is, if in a multiple linear regression, we are given a set of predictor variables, we need to select just subset of those variables. We call it the best set model to be included in our regression model. So we already learned about backward elimination. We also learned about forward selection. And in this video, we will focus on the stepwise procedure. Basically, stepwise procedure is quite similar with the forward selection. That is, we start with a null model, and under a certain mechanism, we will end up with the final model consisting the best case predictors to be included in the model. However, the difference with the forward procedure is that with the forward selection, is that during this process from the null model to the final model, when we add the predictor variables one at a time, there is a certain specific mechanism that makes it different with the forward selection procedure. Let's see how it goes. So, in stepwise procedure, we start with the null model, that is the model containing only a constant beta naught. And then, again, similar with the forward selection, we do PET test by running actually a simple regression with each of the predictor variables, P predictor variables, each of one of them as the predictor in the simple linear regression. And then, according to those PET tests, then we will choose XG with the smallest p-value or the largest absolute t statistic value. And let's say the chosen XG be our X1 star. So then we have our model, the best model with one predictor is by using X1 star as the predictor. And then in here, this is starting from this step, it differs from the forward selection method in the sense that, okay, now we want to add the second predictors. So then we will add the XJ with the second smallest p-value, try to add that in our model. So then in here, we have this one, okay? We have beta naught plus beta 1 X1 star. And let's say that the second one that we add, we just denote it as X2 star. So we have this model. But then after this, we have to revise. We have to revise the contribution or the role of X1 star after including X2 star in the model. Is X1 star still significant? Because there is the possibility that X1 star might no longer significant when it has to work together with X2 in the model. So if the answer is no, then we should exclude X1 star, and then we set this new variable as our new X1 star. So we have a new simple regression model given by beta naught plus beta 1 X1 star, but this X1 star is different with the first one that we have here. And then after that, we keep repeating this procedure. But if X1 star is still significant after adding X2 star in the model, then okay, this will be the best model with two predictors. And then we continue the procedure trying to choose the third variable to be included in the model. And then let's say the chosen one, we denote it by X3 star. So we have this one. And again, we have to we have to do the iteration. So this is kind of like a repetitive process. And then we will stop when no more variables to be included or excluded from the model. Looking at this procedure, there is a possibility that we will have infinite loop, right? Because here going back to this step and this one also going back to this step. So to avoid the infinite loop, we set a constraint that P1 should be less than or equal than P2, where P1 is the kind of probability for adding the variables into the model, and P2 is the kind of probability for removing variables from the model. So we can say that in stepwise procedure, we start with a constant model, then we include one predictor variable at a time according to their significance in model testing. And the significance of a set of variables might change upon addition of a new variable. Thus, the procedure is repeated until the best set is obtained.